Hi guys, happy first day back from spring break. I'm sure you're missing me terribly, but what we are starting today is our investigation into trig, and that'll take us over the next couple weeks. So I think that saying trig or looking at some of these things hopefully invokes some memories for you back from geometry. Some of this should be review, and some of this is going to be very new for you. When we talk about trig, the main thing, or I hope that you remember sine, cosine, and tangent. Those three ratios I have on the top. Or that SOHCAHTOA that's there. That's just a little mnemonic device to help you remember the ratios of sine, cosine, and tangent. But there are three other ratios that I don't think you investigated in geometry. They are called cosecant, which is abbreviated by the CSC, secant, the SEC, and cotangent, COT. Now, if you notice, those three ratios are just reciprocals of the ratios above it. So those three are called our reciprocal ratios. But together, when I talk about my main trig functions, I'm talking about all six of those as one big unit. Now, that's great, even if you remember some of the stuff about sine, cosine, and tangent, but you need to know when you see those words adjacent, opposite, and hypotenuse, what they actually mean. So just as kind of a quick little way to remember, adjacent usually means the side that is next to the angle. Opposite is the side that's across from the angle. And hypotenuse is the side that is across from 90, from the right angle. Now, whether you realize it or not, this idea of adjacent and opposite all hinges on being dependent upon what angle we're looking at. So if you look at those first three, first of all, I should have marked the right angle. You can't always just assume it's 90. So I should have marked in number one, there's the right angle. In the middle one, there's the right angle. And on the one on the end, there's the right angle. So again, this idea of adjacent, opposite, and hypotenuse will change depending on what angle or what theta we're looking at. That little goofy symbol, it's a Greek symbol, it's called theta. So in the first one on the left, if I am looking at this angle right here, the side across from that angle is what we label as opposite, it's my O. The side across from 90 is my hypotenuse. And the other side, or the side next to the angle, is what we call adjacent. Same thing in the middle. I always usually start with the side across from the angle, that is my opposite. The side across from 90 is my hypotenuse. And the side that's next to the angle that isn't the hypotenuse is my adjacent side. And similar with my last one there. Start with the angle in question. Side across from it is my opposite. Across from 90 is the hypotenuse. And the side next to the angle is the adjacent. Now, it's not that I'm going to ask you to label that every single time we have a triangle. That's not the case. But that is something you need to be thinking about in your head. Okay, so if you look at this triangle down here, what's nice about it is that I gave you all three sides. Because there will be some in a second that I don't give you all three sides. But I gave you all three sides. So not that you have to do this every time, but just while we're starting, what I would probably do is go ahead. If this is my angle in question, I might label these sides. So the side across from it, or my 4, is opposite. The side across from 90 is my hypotenuse. And the side next to the angle is my adjacent. Once we know that, we can fill out these ratios pretty easy because what you need to think for yourself, sine. Sine is opposite over hypotenuse. So in this case, that would be opposite over hypotenuse is 4 over 5. Cosine. Cosine is adjacent over hypotenuse. In this case, our adjacent is 3 over 5. And tangent is opposite over adjacent. In this specific triangle, that would make it 4 over 3. Now, those other three functions, you can think of this one of two ways. You can either think of it as remembering which functions pair up, like for instance, cosecant is reciprocal of sine, or you can know that cosecant's ratio is hypotenuse over opposite, so that would make that 5 over 4. Same thing with secant. You can remember that secant and cosine pair up, or you can remember that secant is hypotenuse over adjacent, which would make that 5 over 3. And similar with cotangent. Either remember that cotangent and tangent pair, or cotangent is adjacent over opposite, which would make that 3 over 4. Okay, so what I want you to do is on this next part, pause the video, and try number 3. Okay, so hopefully we agree. All right, now in number 4 at the bottom of the page there, what I want you to do is go back to that same triangle, and I'm going to erase what I labeled because it's going to change. Now what I want, instead of thinking angle theta that's marked there, or that angle A is what I was doing, I'm not going to worry about that guy. I want to worry about angle B up here. So I want to use the exact same triangle, but I want to list the ratios in terms of angle B. So that changes the game, because now 15 is my opposite. 17 is still my hypotenuse. That's the only thing that will remain consistent. And 8 is my adjacent. So again, pause the video, take a second, and fill out those for my angle B, the same triangle, but in relation to angle B as opposed to angle A. And again, hopefully we checked it, and hopefully everything is great. We agree. So on the front, I think there's lots of things that you know. Yes, cosecant, secant, and cotangent are new. That's a new concept for you, because I think in geometry, you kind of restricted yourself to sine, cosine, and tangent. But it's still the same idea. The idea of identifying these sides into the categories of either adjacent, opposite, or hypotenuse, and then coming up with the ratios. Now, when you flip on the back, 5 and 6 are asking you to do the same thing that we did on the front, but if you look at this, you are missing a side. So the first thing I have there, well, I should have marked the right angle, but the first thing I have there is, do you remember the Pythagorean theorem? I hope that you remember the Pythagorean theorem. That's something you learned in middle school. Okay, when you talk about Pythagorean theorem, a squared plus b squared equals c squared, but do you really even know what that means? So Pythagorean theorem is used to find a missing side. Whoops. Things are getting goofy on me. Let's start it there. So Pythagorean theorem is used to find the missing side of a right triangle. And yes, it has to be a right triangle. If it's not a right triangle, you can't use the Pythagorean theorem. And hopefully you remember A and B are the legs of the triangle, meaning the two sides that form the right angle. C has to be the hypotenuse. Okay, so in something like number 5 and number 6, I can't move forward until you find that missing side. So the first thing I'm going to have to do is I'm going to have to set up Pythagorean theorem. So what we need to know is the 30 and the 16 form the right angle, so those are my A and B in either order. So I would say 30 squared plus 16 squared equals c squared. That's my hypotenuse. Now, 30 squared plus 16 squared. You may or may not know what those are off the top of your head. If you do, awesome. If you don't, use your calculator. I just did it on my calculator. 30 squared was 900, 16 squared was 256. So if I add them together, I get 1156. Okay, and hopefully you know, because of all the work we've done by now, that at this point we have to take the square root of both sides. Now, if this is great for me, this will work out to a nice, friendly whole number, and it does. The square root of 1156 is a whole number. It happens to be 34. Okay? If any of you were thinking, what happens if it's not a whole number? Here's what I can tell you. You are not allowed to give me a decimal answer. You're going to have to simplify the radical. So again, like we've talked about so often right now, all the skills we've been using, they keep building on each other. We keep revisiting them. So when we simplified radicals a couple chapters ago, now this is back if we need it. Best case scenario, this works out to a whole number and we don't have to. But like I said, if it's not, we have to simplify the radical. Okay, the other thing you will notice on this number 5 is that I didn't ask you for all 6 ratios. I only asked you for 3 specific ratios. So the first thing I asked you for was the tangent of A. So that's where you have to know, okay, I have to know my ratios, tangents opposite over adjacent. So it'll probably be helpful if mine were, I know yours are labeled A, B, and C, mine were not. So let me throw that in there. So the tangent of A, we're talking about, A is right here. So tangent says opposite over adjacent, which in this case would be 16 over 30. Now, something that happens in this ratio that did not happen on the front, this ratio can be reduced. If you can reduce them, you should reduce them. So if I reduce this one, it becomes 8 over 50. Okay, the second one asks for the secant of A. Secant is hypotenuse over adjacent. So in this case, in relation to A, our hypotenuse is 34 and our adjacent side is 30. But again, if you can reduce it, which you can here, we need to. So this reduces as 17 over 15. Now look at the last question there. The last one kind of changed the game. Now we're talking about the sine of B. So now we're looking at this angle right here. Sine is still opposite over hypotenuse, but since I switched angles, the opposite side changes. Now the opposite side is 30, and the hypotenuse is 34. So this is 30 over 34, which can be reduced to 15 over 17. So in my opinion, when I ask you for all 6 ratios, sometimes it's easier because you know which ones pair up and you can just flip them to find those reciprocal ratios. When I only ask you for a couple, then you have to think a little bit harder. Now, if any of you are wondering, do you have to memorize these ratios? Yes. I will not give you SOHCAHTOA. I will not tell you what they are. So eventually, you do need to learn these ratios. So the quicker that you can commit them to memory, the easier things are going to be for you. Okay, look at number 6. So again, you have some more information than I do. So I have this labeled A, B, and E, and this is your right angle. Okay, so what you need to notice right away is I am missing a side. Now, I don't care if you call that missing side A or B. What you need to know is it's one of the legs. So I'm going to set this up and say, I'm going to call it A. Actually, I'm going to call it B. So I'm going to say 5 squared plus B squared equals 8 squared. Okay, so go ahead, see if you can find that missing side, and see if you can find those three ratios. So pause the video and see how you can do. Okay, so hopefully we agree. This is one of those ones where you did not come out to a nice pretty whole number. We cannot simplify radical 39, so I'm going to leave it as radical 39. Now, strategically, the 3 questions I asked you did not end up with a radical in the denominator, but you know from what we've done previously, if you have a radical in the denominator, you do need to fix that. Okay, and then let's look at the 3 at the bottom. So the 3 at the bottom started out with, I gave you one of the ratios and then it asked you to find the other ones. That means all other ones. So what I'm going to do here, I'll do a triangle that looks like this. It says the tangent of E equals 5 over 12. You have to know that tangent means opposite over adjacent. Okay, so I'm going to draw a triangle. I gave you one already. I'm going to label one of the angles E, not the right angle, okay, because we never find ratios of the right angle. It's always one of the other two. So I'm going to call this guy E, but really it doesn't matter. Now, if this is my E, its opposite side is 5. Its adjacent side is 12. And I already know what tangent is, but I don't know what the sine is. I don't know what the cosine is. We know the tangent is 5 over 12. I also don't know what the cosecant is, the secant, or the cotangent. Okay, so just like we did up top, I need to find the missing side first, and then find the ratios. So take a second, pause the video, see what you can do. Okay, this one was a little bit friendlier. The missing side worked out to a nice pretty whole number. I found my ratios, nothing needed to be reduced. That was great. Okay, look down at 8 and 9, they're the same thing. I just didn't give you a triangle first. So 8 says if the tangent of B is 3/7, find the exact value for the remaining functions of B. So I have to draw myself a right triangle because we know this is right triangles. I have to label one of the angles B, it doesn't matter. But again, just like before, tangent, this is tangent. Remember, tangent is opposite over adjacent. So the opposite side is 3, the adjacent side is 7. So I have to find the missing side and then all the ratios. So try that, pause the video, try that, and see what you get. Okay, so let's look at this one. So this was not a pretty whole number. We ended up getting that the hypotenuse was the square root of 58. Then with sine and cosine, when I went to build those ratios, that had a radical in the denominator, which I couldn't leave, so I had to fix those. So I had sine, cosine, tangent, cosecant, secant, cotangent. Okay, same thing with number 9. Go ahead, draw yourself a triangle, see if you can figure this out. Pause the video, and then we'll check. All right, guys, I only have a few more seconds to tape, so go ahead and check these answers real quick. One thing I want to point out, you don't always have to be given the tangent ratio to start. So we could do these with given another ratio.